In this section, we're going to start our general process of implementing a stack from scratch based on the ADT we talked about last time, as well as our kind of general stack concepts that we've been reviewing this whole time. Now, one thing you may notice here is that I don't have BlueJ open yet. We are going to be spending certainly a lot of time doing it. I'm actually going to be coding the entire thing from scratch this time instead of using the example from the book. Or rather, I should say, I'll be redeveloping what the book already has. What we'll be working through will be very similar. The reason I don't have BlueJ open right now is because we're just getting started. And really, I shouldn't be opening up my editor and starting to code before I have a basic idea of how I'm going to build out this thing, right? How am I going to build this stack data structure, right? As a quick review, the idea behind the stack is that we have some linear collection of elements. So here I have these kind of 5 different rectangles there representing the stuff inside of my stack. And then I have the ability to add stuff to the top of that stack or remove stuff from the top of that stack. Over here, right, we're just going to say that the top of the stack, right, this arrow here, is indicating the most recently added thing, right? And if something's removed, then this arrow will point down to the thing that was added before that thing. Before we actually start typing, let's think about how we might be able to do this. Well, the first thing we need to think about is how to store the information in the stack. And really, we only know one way right now, which is using arrays. So a basic idea is to say, okay, let's use an array to store the information in our stack. For example, maybe here the first position is going to be the 0th index, and the first index, second index, third index, fourth index, and so on, right? So you can imagine we have an array with a bunch of spaces in there, and that's where we'll store the data inside of our stack collection. One thing I need to consider if I'm going to commit to using an array to store this thing is that arrays have a fixed size. So maybe you can imagine that I'd extend this picture up a little bit and that there's some more space for some other units here, right? So maybe I can put in 3 more elements into the stack, right? Maybe I have these other indexes, right? Index 5, index 6, and index 7. The issue with arrays is that they have a constant size or constant capacity. When we talked about exceptions earlier, we realized that, there's never really any time that adding an element to a stack should fail. Well, if our underlying implementation is going to be array, we do need to actually worry about that, because it might be the case that I go to add an element and that array that I've used to store that stack information is already full. And what we'll need to do is find some way to address that. Keeping in mind that our collection is going to be storing objects, we can think of it looking like this, right? Here, right, we have, again, our array has been drawn out, right? Here we have from 0 to 6. And then each of these slots, right, if we wanted to draw a more accurate picture, we would have this little arrow, right, this little pointer going out and saying, the element that's being stored here in this index, right, is being stored, somewhere else in memory, right? So objects are somewhere else in system memory, right? There's really some big cloud here called RAM, right? This is really where your main system memory is, right? Where the rest of your stuff is being stored. And then we have some fixed length array that stores the stuff that's actually in my stack. Right now, we have this drawn out with a stack of capacity 7. But again, our issue, right, is what if we want to add something new? Normally, when we create an array inside of Java, we are essentially asking for a memory allocation of this size. Enough memory to store 7 elements, for example. Well, the issue is this happens at some point in your program, then other stuff's going on. And during that time, there might be some other variable that occupies the space right before, right after your array, right? So if that space right after your array is being used, that means you can't just expand your array, right? You can't just start using that slot 7 at slot 8. The reason you can't do that is because somebody else is already using that storage location. Instead, what we need to do is try to allocate a brand new array, right? So I create another array off to the side, and this one will be slightly larger. Let's just say this is one that has 8 elements in there. So let's just draw this in really quick. So imagine we have this new array off to the side, right, that goes from 0 now to 7. So the way we could support resizing then, right, if we're not allowed to just extend what we already have, is to build this new big array and then copy everything over, right? So whatever is here, right, so let's say, we have object A here, we copy it over here. Maybe we have B here, that gets copied over here. And then that happens, right? So the rest of these get filled in with whatever was there originally. And then we have this new blank space, right? This new position I've created is now going to be empty. And so now I can create a new element or store a new element into that position. So that's going to be my basic approach. In order to make sure that my stack can store as many elements as I want, I'll check to see when I run out of memory in whatever array I currently have, and then I'll make a new second array that's bigger than the previous one, and then copy all the stuff that was already there into the new one, right? So here we had A, B, maybe even have a C, and just move all that stuff into the new one. That means I'll have a second array with more space at the end, right? We have an extra element here. This will be an easy way to support adding as many elements as we want. The only thing we really need to be worried about is the fact that this will take time, right? It takes time for us to make a copy of this array into a new location. And that's something we would prefer to avoid, but for now, we kind of just have to deal with it. Once we get to the next chapter, which talks about linked structures, we'll introduce a new data structure that lets us easily add or remove elements. And it'll turn out that it's almost ideal for implementing a stack. For now, we gotta just worry about manually resizing an array whenever it ends up that we have too many elements in it.